So now let's look at the net ionic equations. So we're going to do it for a reaction between ammonium phosphate and zinc nitrate. So I've already written out the complete equation. Now, when you look at that, you can predict that this is a double displacement reaction because you have two different compounds that are reacting with each other. And so those two different compounds that were reacting resulted in two new compounds being created. So when you are examining this, if we started with just the ammonium phosphate, we know that ammonium, that's a polyatomic ion in H4 plus, phosphate is PO4 3 negative. Zinc is the transition metal, but it's one of the three that you should already know the oxidation for because they don't have multiple oxidations. Both zinc and cadmium are +2 and silver is +1. And nitrate, another polyatomic ion, is NO3 negative. So when you write the formulas for ammonium phosphate reacting with zinc nitrate, and then you swap the cations or anions. Remember, cat for cat, and for an, but you can't do a cat with an and. So I end up with ammonium nitrate and zinc phosphate. Now, as you see here, I have the states of matter, and the states of matter come from using the solubility table. So I find where ammonium meets up with phosphate and tells me it's soluble, so that means it's aqueous. Same thing with zinc and nitrate and ammonium and nitrate. Again, I'm just using this table. If it says it's soluble, it's aqueous. But when I look up zinc with phosphate, so I would go to phosphate and I come over to zinc, it says it's insoluble, so that means that's going to be a solid. Now I need to balance this equation, and I like to start with polyatomic ions, but there's 3 polyatomic ions. So this time I'm going to actually start with zinc. Zinc there's 3 in the product. So I'm going to put 3 here, which changes my number of nitrates to 6. There's to 6. Okay, come over here, there's 1 nitrate, so I put a 6 in front of the ammonium nitrate, which gives me 6 ammoniums. There's only 3 ammoniums here. I'll put a 2 here, that gives me the 6 ammoniums and the 2 phosphates, which go back to my 2 phosphates on the end. So now I have a complete balanced equation. So what I'm going to do with this equation is I'm going to break it up into its ions so that I can get the complete ionic equation, and then we'll do a net ionic equation. So if we start here with the ammonium phosphate, there's 6 of them. So we're going to say 6 NH4 plus. And so now we're going to move on to the phosphates. How many phosphates do I have? Where there's 2 phosphates there, so then I'm going to take those phosphates and I'm going to find out how many of those I have as well. All right, so that gives me those 6 ammonium ions. Now when I look here, I have 2 phosphate ions. Okay, so notice that I broke down the ammonium and I broke down the phosphate into their individual ions. I'm going to do the same thing for the zinc and the nitrate. So there's 3 zincs here. And zinc, again, is in group 12, so it has that charge of +2. And nitrate, there's 6 of them, so I'm going to have my 6 NO3 negatives. Now these are all the ions that make up the side of the reactants. We're going to repeat the process for the products. However, if it is not aqueous, I cannot break it up into ions because remember, it is the water that separates the ions from each other, and a solid is not broken up into ions. So when I come on this side, I have my ammoniums again. So I have 6 NH4 plus my 6 nitrates. So I have the 6 NO3 negatives. But look, this is a solid. So I can't break that up. I can't break that up into the individual ions for that zinc phosphate. So I'm just going to have to put that is the zinc phosphate. So here I have plus Zn3 PO4 2. Now, this is what we call a complete ionic equation because I have all of the ions, and then I also have my precipitate over there, which is that solid, because when you mix these 2 liquids together, this is going to come out as a precipitate. That's what it means by precipitate. It's going to come out as a solid in that chemical reaction. So now I need to do what's called a net ionic equation. So anything that's on the reactant side and the product side, any ions get canceled out. So when I take this net ionic equation, I'm going to have to evaluate both sides of this equation. All right, so let's look at it. So on the reactant side, I see I have 6 ammonium ions, and I also have 6 on the product side. So those canceled out. If I look at my zincs, I have, well, phosphate, I have 2 over here. I don't have any phosphate ions over there. I look at my zinc ions, there's 3 over here. I don't have any zinc ions over there. I see my 6 nitrate ions here and my 6 nitrate ions here. So when I evaluate both sides, I come up with what's called a net ionic equation, where I'm gonna, anything that's not canceled out, I'm gonna keep those. So my net ionic equation basically is stating that my 2 phosphate ions plus my 3 zinc ions are going to create that zinc phosphate, because everything else is going to end up canceling each other out. All right, that is it for how you work an ionic equation. Figure out those ionic equations. Bye-bye.